Good day, viewers. I welcome you to today's class on hypothesis testing. Hypothesis testing is a vital topic in statistics that enables decision makers to make quality decision. My name, once again, is Dr. Chris Esekaibe. I'm a chief lecturer and a member of the academic board of one of the most prestigious polytechnics in Nigeria. I hold a doctorate degree in mathematics, a master's degree in mathematics, and a bachelor degree in statistics. I specialize in numerical analysis, data analysis and modeling, statistical analysis, and scientific computing. If you are a firm, an AI firm or a research institute, I can partner with you in your research work. I work in Nigeria and I live in Nigeria. Why not? I can be part of your work, of what you are doing. I can be a member of your team of mathematicians or statisticians for developing advanced mathematical models and algorithms for artificial intelligence. I'll be looking forward to hearing from you. I've written quite a number of books in mathematics and statistics, and I have scholarly publications in renowned publications in Nigeria and outside of Nigeria. And I also have presented papers in renowned conferences in Nigeria and outside Nigeria. My contacts are +234-80-330-21903. This first one is the WhatsApp, so it's also a WhatsApp number. Then the second number is +234-7066-297535. And my email is chrisdavid2015@gmail.com. I will be looking forward to hearing from you, and it is time we go into the business of the day, hypothesis testing. You will find my contacts in my profile and description of my channel. My channel is Dr. Chris Esekaibe. The channel comprises of mathematics and statistics topics, especially numerical analysis and statistical analysis. The essence is to share knowledge. The essence of the channel is to share knowledge across the globe. If you have challenges in any topic in mathematics or statistics, especially in numerical analysis and statistical analysis, that you want me to really throw more light on or teach and upload, why not? You can make a comment. You can put it in the comment section and it will be treated accordingly. So I'll be looking forward to hearing from you. I got a call from Rwanda, an MSc student who specializes in numerical analysis. He called, sent a WhatsApp message, and we were able to communicate. So I'll be looking forward to hearing from you so that I can be part of what you are doing. The essence is to be part of those improving and sharing knowledge in mathematics and statistics across the globe. So please permit me to print this apart. You will see it in my description, a description on part of my channel. Now, hypothesis testing. It will interest you to know that most important aspects of the theory of decision has to do with hypothesis testing. That's what we call the theory of decision making. This theory of decision making depends on a large extent on hypothesis testing. Now, before we define what a hypothesis is, it will be good to define what we mean by the word thesis. Thesis. So a thesis is something that has been proven to be true. You can say a thesis is something that has been proven to be true. That is what a thesis is. Something, it can be a statement that has been proven to be true. It has been tested and it has been proven to be true. So, in other words, a hypothesis is something or statement that has not, underline the word not, that has not been proven to be true. So you can see the difference. A thesis is something that has been proven to be true, to be correct, while a hypothesis is something or a statement that has not yet been proven to be true. That has not been proven to be true. It is yet to be proven to be true. That is what a hypothesis is. It is a statement, a hypothesis is a statement about a population or about a population distribution. So it is a statement about a population or population distribution. That is what a hypothesis is. It is a statement that is yet to be about, it is a statement about a population or a population distribution that is yet to be proven to be true. The statement is tentative as it implies some assumptions which may be found valid or which may be verified later to be true or false. So what then is hypothesis testing? So hypothesis testing has to do or can be defined as the process of determining. Hypothesis is the process of determining whether a given hypothesis is true. Hypothesis testing is the process of determining whether a given hypothesis is true or not. Whether it is true or not. That is what hypothesis testing implies. It is the process of determining whether or not a given hypothesis is true. If the population is large, the hypothesis is now tested on the basis of the outcome of a random sample that is drawn. So in a situation where you have a very large population and the population cannot be handled, so a part of the population which is called sample will be drawn from the population, and the test will now be based on the sample statistic. If the population is known, the test will now be done on the population parameters. By now, a statistic is an observation that is drawn or that is calculated or computed from a sample. That is what a statistic is. So you can carry out tests on sample statistic or population parameters, while a parameter is a quantity that is computed from a population. So a statistic describes the sample, while the parameter describes the population. So these are the key definitions we need to understand. So hypothesis testing helps us a lot in the theory of decision making. It's a very vital aspect in the theory of decision making. It helps us to take quality decision, and a thesis is something that has been proven to be true or correct, while a hypothesis is a statement or something that has not yet been proven to be true. So now permit me to clean this part of the board as we go to the types of hypothesis. Types of hypothesis. We have two types of hypothesis. Types of hypothesis. Types of hypothesis. Types of hypothesis. The number one is called the null hypothesis, and it is denoted as H subscript 0. The number one is the null hypothesis, and it is denoted as H subscript 0. This hypothesis is an assertion about the value of the population parameter that we hold as true unless we have enough statistical evidence to conclude that it is false. So it is tested under the assumption that it is true. It is a hypothesis that states that a statement is assumed to be true, otherwise tested to be false. So the null hypothesis is assumed to be true. It's a statement that is assumed to be true unless it is tested or proven to be false. It's a statement about the population parameter. Then the second type of hypothesis is the alternative hypothesis. Alternative hypothesis. And this one is denoted by H1 or HA, capital letter A, alternative hypothesis. This hypothesis contradicts the null hypothesis, or you can say this is a negation of the null hypothesis. It contradicts or negates or opposes the null hypothesis. For instance, if the null hypothesis is saying there is no significant difference between two items or two quantities, that the two quantities are the same, the alternative hypothesis will negate it. It will oppose it or contradict it. If the null hypothesis is saying there is no significant difference between two variables, the alternative hypothesis will say there is a significant difference between the two variables. So the statement between the two variables are opposite. The statement between the null hypothesis and the alternative hypotheses are opposite. The statements are opposite. They are directly opposite. If the null hypothesis is saying the population mean is equal to this, the alternative will say the population mean is either not equal to this, or is greater than this, or is less than this. So it negates it. So now this will now take us to what we call decision rule. You know, in hypothesis testing, these two hypotheses cannot be accepted and the two of them cannot be rejected. It is only one that must be accepted per time. It's either you accept the null hypothesis and reject the alternative hypothesis, or you accept the alternative hypothesis and reject the null hypothesis. So these are the two types of hypothesis we have in hypothesis testing. It's a very valid topic in the theory of decision making. You have to decide, and what helps you to decide is what we call the decision rule. And let's look at the decision rule. There's a rule that guides your decision. In statistics, that rule is called the decision rule. This rule guides you whether to accept the null hypothesis or reject it. And of course, you cannot accept both hypotheses and you cannot reject both hypotheses. So there are two rules that are two patterns of taking decision. Number one, we make use of what we call the table value. When you have the test statistic, the hypothesis testing has procedures. One of the procedures is that you will look for a suitable test statistic that is good enough to analyze the data. Then you get what we call the test statistic. Then, of course, a critical region or a level of significance will be given, alpha. That alpha will help you to get the table value depending on the test, the statistical test you are using, or the test statistic. It may be student t-test, it may be z-test. So it will also lead you to what we call the table value. So like the student t-test has what we call the table. We have the student t-table, we have the z-table, we have the chi-square table, we have the table for the F distribution, that is the ANOVA, analysis of variance, and so on and so forth. So when you get a value for the test statistic based on the test statistic you have used, you will now go and get the table value from the table. If it is the student t-test you have used, for example, you will get the table from the student t-table. It is available. So now the first rule says if the calculated value is greater than the table value, comma, you reject HO. That is the null hypothesis will be rejected. So this is one rule that helps you to take the decision of rejecting HO. Then you now say otherwise accept it. So that means if the calculated value is greater than table value, HO is rejected. But if the calculated value is less than the table value, HO is accepted. That is what we mean by this, otherwise you accept it. That is the decision rule number one. Then decision rule number two, there is what we call the probability value. That probability value is called P value. So if our P value is greater than our critical value alpha, is greater than, or let me use it in words, is greater than the critical value, our critical value is denoted as alpha, then you accept the null hypothesis HO and reject H1. Of course, if HO is rejected, it means automatically H1 is accepted. If HO is accepted, automatically it means H1 is rejected. So you cannot accept HO and H1 at the same time, and you cannot reject both of them at the same time. So these two conditions help us to take quality decision on which of the two hypotheses to be accepted or rejected. Now there may be what we call errors in hypothesis testing. As a result of carrying out your testing, you may commit one or two errors. So please permit me to clean this part of the board. I hope it is taken note of. Errors, this now leads us to errors in hypothesis testing. In the process of carrying out your test, you may commit an error. So let us look at the errors that may be committed, that you may likely commit. So errors in hypothesis testing. Errors in hypothesis testing. Now, we cannot be 100% confident about the inference that we do, about the test that we do. You know why? Because there may be variations from one sample to another sample, and this variation may not be easily eliminated until the sample is as large as the population itself. So the conclusion drawn may lead to an error. So if, for instance, you take different samples from a particular population, there may be variations in these samples. The only thing that will make this variation to not to appear is when the sample itself is as large as the population. So these variations, when inference is made on a sample that has variation from another sample, it may lead to an error. One sample from a population, you may accept HO. Another sample from the same population may reject HO. So this variation is not good. So now the two types of errors that are likely to be committed, number one is called the type 1 error. Type 1 error. You are likely to commit a type 1 error. What is type 1 error? Type 1 error simply means it's a wrong decision of rejecting a true null hypothesis. It is a wrong decision of rejecting a true null hypothesis, HO in bracket. Underline this word true, and also underline this word wrong decision. So now type 1 error simply means when the null hypothesis is supposed to be accepted and you now wrongfully rejected it, you have committed what we call a type 1 error. It simply means rejecting the null hypothesis when it is supposed to be accepted. So by doing that, you have committed what we call a type 1 error. It is a wrong decision of rejecting a true, the null hypothesis is true, a true null hypothesis, but it was rejected. And when it's rejected, you now go and take the alternative hypothesis. So probability of committing a type 1 error is alpha alpha is also called the level of significance of the test. So there's a probability, and that probability alpha is the level of significance. Then the second type of error you are likely to commit is called the type 2 error. The type 2 error. What is the type 2 error? This is the wrong decision of accepting a false null hypothesis. This is the wrong decision of accepting a wrong null hypothesis. HO. You see it now? You can see the two types of error. This one is type 2 error. Now, the null hypothesis is wrong. It's supposed to be rejected. But on this ground, you are accepting it. You have committed a type 2 error. It is a wrong decision of accepting. While type 1 error, the null hypothesis is true, but you are rejecting it. Type 2 error, the null hypothesis is wrong, but you are accepting it. So, and now the probability of committing a type 2 error is beta. Now, beta can also be calculated in a given test. So the probability, there's a likelihood that one may commit a type 2 error, and that probability is beta. It's denoted as beta in test of hypothesis. Then the probability that you may commit a type 1 error is alpha, and that alpha is the level of significance. Now, every statistical test has a power. So the power of the statistical test, the power of the test you are running is 1 minus beta. Beta, of course, you are told is the probability of committing a type 2 error. So the power of the statistical test is 1 minus beta. 1 minus beta. So it is good you take note of this. So these are the two errors in hypothesis testing. I hope this is taken note of. Now, I want to take us to what we call the general procedures of hypothesis testing. There are procedures, there are step-by-step procedures. So permit me to clean up this part of the board. General procedures for hypothesis testing. There is a general laid down procedure that must be followed step by step. That must be followed step by step. So we call it general procedure for hypothesis testing. There are step-by-step procedure that must be taken. Step number 1, state clearly the null and alternative hypothesis. State clearly the null and alternative hypothesis. That is step 1. The HO and the H1 must be clearly stated. Then step number 2, you must specify the level of significance alpha. 2, specify the level of significance alpha. I told you alpha is the probability of committing a type 1 error, so it must be clearly stated. Then step 3, choose an appropriate test statistic. 3, choose an appropriate test statistic. So depending on the nature of the data, there is an appropriate test statistic for each set of data. So you must choose the one that is appropriate. Then 4, make necessary computations. Make necessary computations. That means you have to compute the test statistic, and you are also to compute the p-value. You can find the p-value, and you can also calculate the test statistic. Then 5, take decision and make a valid conclusion. Now, after you have made the necessary computation, and of course, then and define your critical region, define the critical region. So the critical region, like that is where you can get the table value and so on and so forth. So all these come under the computation. After you have computed the test statistic, then of course you go and get the critical region, which is the table value. Then you will now compare both of them. That will help you to take a decision and make a valid conclusion. I told you, you can compare the p-value with the alpha. You can compare the p-value with the alpha. Alpha is the critical value. If the p-value is greater than the critical value, you accept HO and reject H1. Or you can use the table value. You compare the table value with the test statistic. If the calculated test statistic is greater than the table value, you reject the null hypothesis and accept the alternative hypothesis. So these are the steps for computing or procedures for testing hypothesis. Now, it may interest you that there are types of tests that you need to know. So we have what we call the two-tailed stroke one-tailed test. So a statistical test can either be two-tailed or one-tailed. If we have a set of hypotheses as this, HO mu is the population mu1 is equal to mu2, or we have another one, H1 mu1 is not equal to mu2. For instance, you are testing the population parameter of two different population. The population mean of the first population is mu1. The population mean of the second population is mu2. So when you say test the hypothesis that the population, the mean of the first population is not equal to the mean of the second population. So when you have it equal to and not equal to, this kind of test is called a two-tailed test. It's called a two-tailed test. When you have equal to and not equal to. Then in a situation where you have HO mu1 is greater than or equal to mu2, H1 mu1 is less than mu2. So this kind of test is a one-tailed test. And one-tailed test, you can see it now when you're having, there are two different statements now. This first one we say test that the hypothesis that the mean of the first population is equal to the mean of the second population. So equal to and not equal to. I told you from the beginning that the H1, the alternative hypothesis, will negate, will oppose or contradict the alternative hypothesis. So if the HO is saying the first mean is equal to the second mean, then the alternative will contradict it, will say they are not equal. So that kind of test is a two-tailed test. But if the question now says test the hypothesis that the mean of the first population is greater than or equal to the mean of the second population, where you see words like greater than, less than, or equal to, is one-tailed test. We have two types of one-tailed test. A one-tailed test is either left-tailed or right-tailed. So for this first one, you can see that when it's having this less than there, it is left-tailed. So a one-tailed test can either be left-tailed or right-tailed. Then if you now have another set of hypotheses, maybe you have HO mu is less than or equal to mu2, mu1 is less than or equal to mu2, then H1, the alternative, mu1 is greater than mu2. This kind of test is also one-tailed. It's also one-tailed, but is a right, because this one is greater than. Once it's having this greater than sign here, it is the right-tailed. So the one-tailed test has two types. It's either it is a one-tailed and it's left-tailed, like this one. The one you see greater than, of course, the last one, it will oppose it. If the HO says it is greater than or equal to, of course, the H1, the alternative, I probably will say it is less than. And that one is left-tailed, because when it's less than, it's left-tailed under the one-tailed test. Then if the HO says the first mean is less than or equal to the second mean, then the alternative hypothesis will negate it or oppose it. It will say the first mean is strictly greater than the second mean, and it's still one-tailed. Anytime you say greater than, less than, greater than or equal to in hypothesis set, you know that it is one-tailed. Then when you see the greater than sign in the alternative hypothesis, you know it is a right-tailed test. So these are the types of tests of these are the type of tailed that we have in the creation or formulation of the null and alternative hypothesis. You must take this, it will be clearly stated from the question, it will be clearly stated from what you want to do, Are you testing the equality between two things? If you are saying testing equality, this is equal, this is not equal, it's a two-tailed. If you are testing, oh, this one is greater than, or the quality of this one is higher than, or this one is lesser than, you are talking about one-tailed test. So the one-tailed test can either be the right-tailed or the left-tailed test. So it is good you take cognizance of this. Now, again, when we talk about test of hypothesis or hypothesis testing, you don't rule out the fact that in statistics we have again two types of tests. We have the parametric test and the non-parametric test. So depending on the nature, there are data that can be analyzed using parametric tests. There are data that can also be analyzed using the non-parametric test. So it is good we also explain this quickly. So let me permit me to clean this part of the board. I believe you have taken note of the procedures and the two-tailed stroke one-tailed test. So when you are forming your hypothesis, you will now know whether your test, it will be clearly stated. If you are doing a two-tailed test, for instance, for the student T test, the student T test has a table. We call it the student T table. That table has value for one-tailed and it also has value for two-tailed. So if you are carrying out a one-tailed test or using the T test statistic, you will go for the T table for one-tailed test. And likewise, you are using the T test, student T test for two-tailed hypothesis. Of course, there is a table value there for the two-tailed value. So you go for that and compare them. So don't take a one-tailed table value from the table, or value. Don't take a student T table value from a one-tailed table and use it to compare a two-tailed test statistic. It is not acceptable. That is not how it goes. One tail goes for the one-tailed table, then two-tail goes for two-tailed table. Even the Z statistic, if you are calculating the Z value, the probability value, if it is one-tailed, you don't divide by 2. If it is two-tailed, you divide by 2 to get the table value. Then you now search and trace it by the side, then you get the Z table value. Now let's quickly look at parametric stroke non-parametric statistics. Parametric stroke non-parametric statistics, or you can call it test. Now let's look at parametric. When you talk about parametric test, this involves parameters, population parameters. It involves population. It involves population parameters like the mean, variance, standard deviation, etc. So those parameters are involved. Now, parametric tests are used for quantitative data. They are used to analyze. They are used to analyze quantitative data. Now, quantitative data are data that are given in measurements. They are given in value. They are measured in values. And again, we have 4 measurement scales. I hope you have not forgotten that. It starts with the nominal scale, the ordinal scale, the interval scale, and the ratio scale. So data that are gotten from interval and ratio scale that can be measured in values. So they are analyzed using the parametric test. Data that are quantitative, that can be measured in values. They are analyzed using the parametric test, and you can measure this data using the interval scale, interval stroke ratio scales. These are the two scales used to measure the data we use when carrying out parametric tests. So I used to analyze quantitative data. Then the second type is the non-parametric test. The non-parametric test, they are used to analyze categorical data, or you can call categorical data are also qualitative data. So these are data that are put in categories. Example, you talk about color, you talk about beauty, data that can be ranked, and the measurement scales that are used are nominal stroke ordinal. These are the two scales used to collect categorical data. The data can be ordered, they can just be nominal data just for identification, and you rank them. So the non-parametric test can be used for categorical data that you can, like for instance, you are talking about high income earners, low income earners, and medium income earners. You are talking about race, white, black, and so on and so forth. You are talking about beauty, highly beautiful, not beautiful, data that are ranked or placed in categories. So they are analyzed using the non-parametric test. Example of a non-parametric test, each of non-parametric is the chi-square test. The chi-square test is given like this: the rank sign test, and so on and so forth. Example of the parametric test, we have the t-test, student t-test. We have the normal distribution test, which is the z-test. We have the ANOVA test, which is called the f-test, and so on and so forth. So these are examples of parametric tests. So it is good you take note of that. It is good you take note of that. So there are conditions for choosing a particular parametric test to use. So let's look at those conditions. I believe you now you have a better understanding of what parametric tests and non-parametric tests are. So when and how to use them, the kind of data that you use them to analyze. So the non-parametric tests are for quantitative data. The parametric tests are for quantitative data that can be measured in values. An example of such tests are the z-test, f-test, student t-test. Then the non-parametric tests are tests that can be analyzed using categorical data or qualitative data. And those data are measured using the nominal and ordinal scale. Example of the non-parametric test, the chi-square test, and the rank sign test, the Wilcoxon test, and so on and so forth. Yeah. The Wilcoxon test is also a part of a type of the non-parametric test. So permit me to clean the board so that we can see how to choose. How do I choose a parametric test? If peradventure I have a problem that I want to analyze, a real life problem I want to analyze, and it involves the parametric test. Now we can give it a simple way, choosing a parametric test. Choosing a parametric test. Case 1. Now you use student t-test, or ordinarily it is called the t-test, when the population standard deviation when the population standard deviation is not known. The population standard deviation is denoted as sigma when it is not known, and when the sample size n is less than or equal to 30. So when you have the sample size n and it is less than or equal to 30 and the population standard deviation is not known, when the population standard deviation is known, that means the sample standard deviation is known, you use the student t-test. So it is for a small sample size. It is less than or equal to 30. If it is below 30, you can use the student t-test. You can use the student t-test, or simply called the t-test. Then case number 2, use the z-test, that is the normal distribution test. The z-test, if the population standard deviation sigma is known and when the sample size n is greater than 30. So when the sample size n is greater than 30, you use the z-test. You use the z-test. So now from here, the test statistic for t is given as x bar minus mu all over the standard deviation all over the square root of n, while the test statistic for z is given as x bar minus mu all over sigma all over root n. Can you see the difference now? This one, x here means the sample standard deviation. X means sample standard deviation, while x bar means the sample mean. Then mu means the population mean. Mu means population mean. You see that? While sigma means population standard deviation. So you can say when the population standard deviation is known, you use the z-test. When it is not known, you use the t-test. That means the sample standard deviation is known. But when you have a sample size that is less than or equal to 30, that is when you use, so two conditions: the sample size must be less than or equal to 30 and the sample standard deviation is known. That is when you use the t-test. Then you use the z-test, which is the normal distribution test, when the population standard deviation is known. That is when the sample size is strictly greater than 30. That is when you use that. So now there are other parametric tests that we can use. We use the regression analysis, or regression analysis. And analysis has two types: the simple or linear regression, or the multiple regression. We use regression when we study relationships, and when we want to study relationships and forecast, we use the regression to study relationships among variables. Then we use the analysis of variance, which is the ANOVA, which is also known as the F-test, when carrying out comparison, or when we are comparing differences among means. We are comparing differences among means, means of various data sets. So that is when we use the ANOVA. The ANOVA is used for comparison, comparing differences, while the regression is to study relationship, and the correlation helps us to tell, it gives us the direction of the relationship. It tells us the strength or the degree of such relationship. Now, having said much, it is good we have a practical example. It is good we have a practical example. Please take note of this. I want to clean it up and I go to a practical example. Then we quickly solve that example and we look forward to calling it a day. We look forward to calling it a day. So much has been said on tests of hypothesis, the types of hypothesis, and the decision rule, and so on and so forth. Please, once again, this is Dr. Chris Esekagbe. Subscribe to my YouTube channel, Dr. Chris Esekagbe. Click on the like button, like my videos, click on the share button, share it among your friends, your colleagues, be part of those sharing knowledge across the globe. And also, you can click on the bell button, the notification button, so that anytime I upload a video, a new video, you will be part of those to get a notification. God bless you as you do that. Now, let us quickly look at an example. I normally write it this way: example. An automatic bottling machine fills water into, so an automatic bottling machine fills water into 5 liter, that is 5,000 centimeter cubic, 5,000 centimeter cubic bottles. Okay. Test the null hypothesis that test the null hypothesis that the average amount filled by the machine, that the average amount filled by the machine into a bottle is at least 5,000 centimeter cubic. So a random sample of 40 bottles was selected. A random sample of 40 bottles was selected, comma, the sample mean was, the sample mean, which is x bar, equals 4999.4 centimeter cubic comma the population standard deviation equals 1.3 centimeter cubic, full stop. Test HO at 5% level of significance. So you have to test at 5% level of significance, or you can say test at alpha is equals to 5%. Of course, alpha is our level of significance. Now let us look at the solution. We'll be taking. We have the 5 steps, the procedural steps for hypothesis testing. There are 5 in number. So the first step, the null and alternative hypothesis. Now, step 1, HO. Remember, test the null hypothesis that the average amount filled by the machine into the bottle is at least. So HO will be greater than or equal to, when you say at least, that means the mean, the population mean, which is the population mean mu, must be greater than 5,000. Then our H1, the population mean will be less than 5,000. So when you say it's at least, that is the null hypothesis. Test the null hypothesis that the average amount filled by the machine into a bottle is at least. So this is at least, is greater than, so the least is 5,000. So is either greater than or equal to that 5,000, which is the population mean. So of course the alternative hypothesis will oppose it, it will negate it. If the HO is saying is greater than or equal to, of course this one will now say strictly less than. So this test, of course, you know, is permit me to share the board into 2 parts. Of course, you know that this is a one tilt test, so this is a left tilt test. So it is a left tilt test. It is a one tilt left. It is one tilt, and it is a left tilt test. Left tail. So you put it in brackets. So that is step number 1. Of course, our level of significance is alpha. So the step number 2, our alpha is equal to 5%. You can put it in fraction and the same thing, or you can say or 0.05. 5% simply means 5 divided by 100, so it will be 0.05. Then, of course, the test statistic to be used is z-test. So we use z-test because n is greater than 30. That means n is 40. A sample of 40 bottles was taken. So n is 40. And the population standard deviation is known, and the population standard deviation is 1.3 centimeter cubic. So you can see that we have the population standard deviation to be 1.3, and we have 40 bottles as the sample. So our n is greater than 30. So our choice of parametric test will be the Z test, because the population standard deviation is known and our sample size is greater than 30. Our sample size is 40. Now the fourth step, which is the critical region. The critical region is Z. That is the table value that will be gotten from the Z table. So all we need to do is just Z at 0.05. You go to the Z table, because since it is a one tilt test, you are not dividing by 2. You just subtract 0.05 from 1, and we have two types of Z table. We have the one that ends at 0.5, and we have the one that ends at 1.0. So if it is the one that ends at 1.0, just subtract 0.05 from 1 and check it directly. If it is the one that ends at 0.5, subtract this from 0.5 and check the value by the side, and you will see that the table value is it will now be 1.645. That's the table value. Then the next one, let us go ahead to compute. So our Z will now be equal to, remember, is x bar minus mu all over sigma population mean all over root n, and that is equal to our x bar, which is, let me write my mu very well. Our x bar, the sample mean, is 4999.4 minus 5000 all over the sigma is 1.3 all over square root of n is 40. So that is what you have there. So if you carry that out, our mu, of course, is the population mean. Our mu is the 5000 centimeter cubic. So our Z from here will be equal to, if you subtract this from this, you are going to have minus 0.6 all over. You carry out this arithmetic, you are going to have 0.20555, and that will be equal to minus 2.919. Of course, probability doesn't take a negative value, so you take the absolute value of Z. When you calculate Z or T and you have a negative value, all you just need to do is to take the absolute value of it. So our calculated Z will be 2 points. Our calculated Z will now be equal to 2.919. That is our calculated Z. Now, permit me to clean the question so that we can go ahead. We have the vitals that we need for the analysis. So permit me to clean the question now so that we can make our decision and conclusion. So that we can make our decision and conclusion. So that we can make our decision and conclusion. Very, very important. Very, very important. So the topic again is hypothesis testing. Now, decision stroke conclusion is very simple. Now, the law says reject HO if Z calculated is greater than Z tabulated. So now we now say since Z calculated and the value of Z calculated is 2.919 is greater than the Z table, our Z table value is 1.645. So definitely the Z calculated, since calculated value is greater than table value, you reject HO. We reject HO and conclude that, look at HO, look at H1. So we conclude that mu, which is the population mean, is less than 5,000 centimeters cubic. So for each bottle, that is the conclusion. So the average amount filled by the machine into a bottle, so we can put it in word, that is the average amount of water filled by the machine into a bottle is less than 5,000 centimeters, that is the volume cubic. You see that? So that is how you make your conclusion in test of hypothesis. You decide, the decision rules are there. Here we use the table value, not the p value. You can also use the p value and you carry out what you want to do. Now, what if in a situation where our n is equal to 10 and the sample standard deviation is equal to the population standard deviation, which is 1.3. That means it is when n is now less than or equal to 30, we can now use the student t-test. So now, permit me to go and say, if peradventure, if n is equal to 10, for instance, and sample standard deviation S is equal to 1.3, use we use the t-test. So now take note of this statement. You use the t-test. So it is the same procedure that will come from the beginning, the same hypothesis, but the test will now be changed to t-test. So take note of this. So that means the z-test will not be used for this particular problem when n, if peradventure n is 10 and the sample standard deviation is given to us the same 1.3. So now it is the t-test that we are now coming to use. Every other thing remains the same, it's just the test statistic. So you now come here and say your t is equal to x bar minus mu all over x all over root n. Our x is the sample standard deviation. So that will now be equal to, of course, the critical value will not be from the z table again. The critical value, I will show you how to get the critical value. The critical value will now come from the t table. So this one, I will call this one the sample standard deviation. The sample standard deviation. So this will now be equal to 4999.4 minus 5,000 all over sample standard deviation is 1.3 all over root 10. So our t will now be equal to minus 0.6 all over 0.411 when you carry out that analysis, and that will be equal to minus 1.46. So the t value cannot be negative, so you take the absolute value of it, that will be equal to 1.46. So our calculated t will be 1.46. Now The fourth point here, if you want to get the critical region for T, critical region for T, you just go to T alpha, comma, n minus 1. So you have n minus 1 degrees of freedom. What is our n? Our n here is 10. So you now have T, our alpha is 0.05, comma, 10 minus 1 is 9. So what you just need to do, just go to the student T table under the one-tailed test. There is a one-tailed test. If you go, if you look, you can download the student T statistical table. The one for two-tailed test is there. The one for one-tailed test is there. Because this test is a one-tailed test, we are testing at least the mean is more at least is 5,000 centimeter cubic. So you will look for the one-tailed t-test table, and when you check, you will now see a column. The column, you will see the probability, the alpha value. You see 0.1, 0.01, 0.025, 0.05. You will see this, our alpha is 0.055%. You will check 0.05 under 9, and the value you will see there is 1.833. 1.833, that's the value, 1.833. So that will be your table value. Now, let us take the decision. Look at it now. Permit me to claim this decision for the Z rule, for the Z test we conducted. This one now is for the T test. It's for the T test. Our HO was rejected for the T test. And for the Z test, our HO was rejected when the Z test was calculated, so we accepted the H1 was accepted, so HO was rejected for the when we conducted the Z test. Now it is the T test. Now we are looking at decision stroke conclusion for the T test. Remember, this one is the T test. We have calculated the T value, the absolute value to be 1.4, and it says that if T calculated is greater than T tabulated, that is the value of reject HO. That's the decision rule. Now, since T calculated of 1.46, this our T calculated 1.46, this our T calculated 1.46, and it is less than the tabulated. The tabulated is 1 point than the T tabulated of 1.833. So at this point, the calculated value is lesser than the table value. So we are now going to accept HO. And conclude that. So we are accepting HO here now, that mu is greater than or equal to 5,000 centimeter cubic. That is, by implication, it means that the average amount filled by the machine into a bottle means that is the average amount of water filled by the machine into a bottle is greater than or equal to 5,000 centimeters cubic. That means HO is accepted. So if the calculated is less than the table value, you accept HO. If the calculated is greater than table value, you reject HO. So when the sample size was 40, we use the Z test, and the population standard deviation was known, we use the Z test. The null hypothesis was rejected. The alternative hypothesis was accepted. Now that the sample size has reduced to 10, the sample size is now 10, which is below 30, we are to use the student t-test. And of course, the sample standard deviation is known to be 1.3. Then we calculated we used the t-test statistic, and we got 1.46. Then from the t-table, we got 1.833. At the end of the day, we were able to accept the null hypothesis. Beloved, we have come to the end of today's class. This is test hypothesis for you. This is how to test hypothesis. We were able to define what a thesis is. We were also able to define what a hypothesis is, and we were able to tell you the difference between a thesis and the hypothesis. And we looked at the types of hypothesis, and then we were able to carry out an example. We told you the difference between a parametric test and a non-parametric test. We also showed you the difference between a two-tailed test and a one-tailed test. I believe you have learned a lot today. Please subscribe to my YouTube channel, Dr. Chris Esekaibe. The essence of the channel is to teach mathematics and statistics topics and share the knowledge across the globe. Please be part of those sharing knowledge across the globe. Share it on your social media platforms, your WhatsApp, your Facebook, and other social media platforms. Click on the like button, click also on the bell button, the notification button, and then subscribe, so that anytime I upload a new video, you will be part of those to get a notification. God bless you. See you again in our next class. Enjoy the rest of the day. Bye.